Hey, welcome back. This is episode 35 of the Salesforce Consumer Goods Cloud TPM Learning Series. Today, Salesforce CG Cloud TPM Processing Services and Off-Platform Calculation Engine Masterclass. Architecting Real-Time Promotion KPI Calculation Engines, Off-Platform Microservices, and High-Performance Sync Pipelines. Let's get into it. Here's what we're covering today. Apex Governor Limits versus Off-Platform Engine Architecture then, Processing Services, HPCE, Microservices Data Flow then, KPI Matrix Ingestion and Dependency Tree Resolution then, Real-Time Sync versus Asynchronous Nightly Recalculations then, Payload Optimization and Off-Platform REST Payload Trimming then, Error Handling, Dead Letter Queues and Delta Synchronization then, Integration with SAP S/4HANA and Enterprise Data Cloud then, Architectural Best Practices for Sub-Second Grid Calculations. Stay for the last one, it's the piece most tutorials miss. Let me explain this simply. Welcome back to the CG Cloud TPM series. Today, we are opening the hood on Processing Services, the high-performance off-platform calculation engine that powers real-time promo grids without hitting Apex Governor Limits.
I've always wondered how CG Cloud processes thousands of product week KPI grids in under 2 seconds. Is it purely custom Apex or external microservices?
Calculating a complex promotion in TPM requires evaluating hundreds of product SKUs across 52 calendar weeks for dozens of financial KPIs simultaneously. Running this multidimensional array matrix directly inside native Apex triggers causes immediate heap size overflows and CPU time limit exceptions. To solve this scalability barrier, Salesforce CG Cloud delegates heavy grid calculations to Processing Services, an off-platform microservice running on Hyperforce. This architecture decouples heavy math operations from the core Salesforce application tier, ensuring sub-second response times during live promo planning. When a user edits a baseline volume or discount percentage on the TPM promotion grid, the web component captures the UI event state. The client calls a specialized Apex controller that packages the promotion headers, tactics, product hierarchies, and custom write-back fields into a JSON payload. This payload is securely transmitted over TLS to the Processing Services API using OAuth 2.0 JWT bearer authentication. Processing Services receives the payload, hydrates the calculation tree, runs the KPI matrix math, and returns the calculated matrix back to core Apex. Processing Services does not blindly compute formulas, it dynamically builds a directed acyclic graph to determine KPI evaluation hierarchy. For example, baseline volume must multiply by uplift percentage before gross revenue can calculate, which then feeds fund accruals and net margin values. The engine ingests active KPI definition records stored in core Salesforce and converts them into optimized expression trees inside the off-platform memory cache. If an architect configures cyclic dependencies within custom KPI definitions, the pre-validation parser catches the recursion prior to execution. TPM architecture mandates 2 distinct execution pathways for Processing Services depending on operational context. Real-time synchronous calls occur directly during user interactive sessions on the Lightning Web Component promotion grid to provide immediate feedback. Conversely, asynchronous bulk processing handles batch re-evaluations triggered by nightly baseline volume updates from enterprise supply chain systems. Architects must implement queuable Apex and batchable frameworks with proper chunking to manage asynchronous API throughput without triggering external endpoint rate limits. A common performance bottleneck in TPM implementations is sending bloated JSON payloads to Processing Services. Passing unnecessary custom object fields across the network rapidly inflates payload size beyond the 6 MB REST synchronous limit. Architects must implement precise payload trimming strategies, stripping out unmodified static attributes and transmitting only delta inputs. Utilizing field set configurations to control what fields Apex serializes ensures minimum payload sizes, drastically reducing serialization and deserialization CPU overhead on the core application platform. In distributed cloud architectures, network glitches or transient service outages can disrupt off-platform processing calls. Architecting a resilient TPM engine requires implementing robust retry mechanisms with exponential backoff logic inside Apex. If processing services returns an HTTP 500 or times out, the framework catches the fault, logs detailed failure context to a custom error object, and then queues the transaction into a dead letter queue. This design ensures user input state is never lost and administrators can replay failed calculations easily. Calculated KPI output stored inside core Salesforce records often need to flow downstream into enterprise ERP systems like SAP S/4HANA or analytics hubs like Data Cloud. Instead of triggering separate REST API calls inside calculation writebacks, use change data capture events on promotion master records. When processing services updates calculated KP is back to core Salesforce objects, platform events publish changed states automatically. MuleSoft or native event adapters stream these events into SAP for condition contract update and fund liability accounting in real time. To conclude our deep dive into TPM processing services, adhere to 4 foundational design principles. First, keep formula complexity inside KPI definitions lean by avoiding deep nested if statements. Second, leverage off-platform caching by pre-warming calculation engines before major planning cycles begin. Third, implement robust batch sizes between 50 and 100 promotions for nightly jobs to maximize throughput without exceeding heap thresholds. Finally, continually monitor calculation metrics using CG Cloud System logs to identify sluggish KPI formulas. Alright, let's wrap up. Here are the key things to remember. Processing services offloads heavy promo grid KPI calculations from Salesforce Core to AWS Hyperforce Microservices. Formula evaluation uses directed acyclic graphs to dynamically resolve complex metric dependencies in subseconds. Architects must optimize JSON payloads using field sets and delta transmissions to stay below 6 MB Apex heap limits. Decouple downstream ERP integration using change data capture events triggered after KPI writebacks complete. If this helped, hit like, it really helps the channel. Next up, TPM_EP36_account_plan_rollups_ERP_sync. See you tomorrow.